All right. I have this presentation. It was originally entitled just the end of cloud computing, but people thought that that was a little too much leaning into the future. So it's really about the return to the edge. And I'll talk about sort of my thinking about cloud and the edge. I came up with this presentation I started to think about it a couple of years ago. And when I first started to talk about the end of cloud computing, what mostly came up was, okay, this is what people thought when I started to talk about the end of cloud computing. This is from Young Frankenstein, if you don't remember the movie, and in particular, that I've gone crazy in thinking that the end of cloud computing actually might happen. I mean, most people, when I started to talk about this, hadn't even moved to cloud computing, and I was already calling the end of it. But if you think about it, one of the interesting parts about technology is that trends absolutely change, and what's popular today often gets replaced by something in the future. And I have this, as part of being an investor, we always have to think about skating to the puck and investing in technologies that are out in the future. And for me, one of the best ways to think about what some of the potential opportunities are is to take away what's popular today and replace it in my mind with something else. And I started to think of cloud computing, which is like the thing right now. What might replace that in the future? Because things always get replaced. I mean, whether it's mini computers or mainframes, I mean, they're still around, but there are new things that sort of fill in the place. And my view is that this is what's happening with cloud computing, and it's happening right under our eyes. So today's world and cloud computing in general is a centralized world. It's really, in a lot of ways, it's a mainframe model. Mobile and PCs, the supercomputer in your palm and PCs all get information from the cloud, right? I mean, when you go make a request, it goes out to the cloud, gets some information, and it comes back. And as we move to the future, my view is that this is all about to change, that the edge becomes a lot more sophisticated. And we have examples already starting to show up. I mean, this whole IoT kind of, expansion right now. Examples are, the most simple example is a self-driving car, which I often describe as a data center on wheels. And I'll talk more about that. But we'll see, flying things. We'll see IoT. All of these devices and things out there at the edge are collecting vast amounts of information that needs to be processed in real time. And I think that shift is what's going to drive a lot of computing back out to the edge of the network. And fundamentally, this is going to be a shift. It will be a shift of where our processing gets done. And I see this as a trend that will naturally occur over the next several years. So today, the automobile has about 100 CPUs. And my concept of the idea that a car is a data center on wheels, this is one plug-in module as an example. And if you link 50 or 100 of these together, you have a data center, and you connect 1,000 automobiles together, and you have a massive distributed network. And a lot of communication now that's occurring, even between cars to other cars and other devices to other devices, will set up the stage for a very new type of architecture, a whole new set of problems when it comes to security, compute, storage, networking. All of that will start to get rebuilt as a result of this new edge paradigm that I think is, right upon us now. And in my mind, data drives the change, right? It's the first time really in our history that we're collecting real-world data about our environment, whether it's vision, location, acceleration, versus what's happened almost every time in the past up until now is most of the information that we've been using have been input by humans, right? We sit in front of a terminal, we input something, it goes to a database, or maybe we scan something, that's sort of the modern thing. But all of that has been textual, and largely textual information going back to databases, and then we retrieve it and operate on that. And now we have devices, I mean, even on our pockets right now, whether it's consumer devices or enterprise devices that are collecting the world around us. Think about the difference between a text or a SQL query versus collecting the world around us in terms of the amount of data and the amount of information that will need to be processed, stored, computed, networked. All of that will start to come into play. Furthermore, data processing will need to occur in real time. So as we collect more information out on the edge, and I use this example of, kind of the self-driving car as the example, but you can think of this in many more cases, whether it's robots that operate on people or drones. If we have to wait for a self-driving car to communicate with the cloud, good luck. It's going to blow right through a stop sign and, will blow through 4 stop signs before the acknowledgement comes back that, oh, that was a stop sign in that image. So that means that devices at the edge are going to not only be collecting information, but will be processing information as well. And I think that's a very big change in terms, because of real-time safety issues and other, just the amount of data will cause that to happen. So this brings up sort of the future. And I started to think about this as well, that we're really returning to a new era, but this has happened a couple of times before in technology. So if you look back, we've gone from centralized to distributed to centralized, and now I'll argue we're moving back to a decentralized world. Now what happens also, what's super interesting in terms of the economics here, in the mainframe era, maybe there were 10,000 devices in the mainframe era, and then maybe that's even mainframe with VT100 terminals hanging off it. Call it 10,000. 20,000, whatever the number is. It's some limited number, right? They're all in an office, and so that was in the mainframe era. Client-server era, there was about 2 billion sort of client-server devices out there. Mobile cloud, 6 billion. And I will venture to say that for edge intelligence and for edge devices, there'll be over 1 trillion devices. And so, we're talking a very, very massive amount of devices that are going to have to be managed, controlled, accessed at the edge of the network. And it probably will go even more than 1 trillion. The other part here, which I think is a bit of a corollary and an adjacency, is not only are we able to collect this real-world information, but we also have the concept and the new paradigms in machine learning that I think will catalyze edge adoption. As we have massive amounts of real-world information, this is going to require machine learning to actually run on the edge, not back in the cloud. Right now, a lot of machine learning runs back in the cloud, which means you have to take all the information from wherever you're collecting it, put it back to the cloud, and then it gets operated on by machine learning. I think that the cloud, while I say the end of cloud computing, it's not going to go away, but I think the cloud becomes a record of last resort on subsets of collected information. And this will be kind of how I see the world sort of dividing up between what happens on the edge and what happens centrally. And I think we're going to start to see this, distribution of compute and processing based on what's happening. So what I'm going to kind of illustrate here is what's happening inside the edge and how I see this. So on the edge, we are going to sense, infer, and act on information, and that the bubble there is the cloud. That's where systems are going to learn. There was a very there was a very famous dogfighter by the name of John Boyd. And John Boyd created this concept called the OODA loop. And the OODA loop stands for observe, operate, decide, and act. And that OODA loop, what it said was that if you have a plane that's less powerful and maybe not as fast as the enemy, as long as you can sense and act quicker than the combat plane, you'll win a dogfight. And so that OODA loop, which means the pilot has to sense things more quickly in real time than your competitor, and if you do that faster, you win. It's agility over power, right? And if you think about that, that's exactly the point of moving information out to the edge and actually acting in real time at the edge, because there's just too much latency to go back to the supercomputers that happen to power the cloud. And so I think this really becomes kind of the thought process in sort of why this becomes important and how some of the future unfolds. Okay, so a couple of things. Sensing. Sensors include cameras, depth sensors, radars, accelerometers, and it's going to be everywhere, generating, as I said, massive amounts of information. It's interesting, a self-driving car right now generates between 2 and 100 gigabytes of data per mile, right? It's collecting, there's many, many sensors on a car. A Litro camera generates 300 gigabytes of data a second. And so we can think about like all of these devices just generating massive, massive amounts of information. And oh, by the way, if it's not generating massive amounts of information, there's going to be lots of these things on top of sort of devices like a car that generates massive amounts of information. There will be other devices out there like a running shoe that will collect data and need real-time processing. So all of these, there's going to be wearables and all kinds of things that are going to be pushing lots of information through themselves that, again, need reasonably real-time processing and probably may not be regularly connected to the back-end cloud in any case, and so needs to operate in that regard. The next part is inference. So once I've collected the information, the edge sensors, when an edge sensor collects this information, it's very unstructured and highly variable, right? I mean, just think about the massive amounts, especially whether it's picture data or video data, it's very unstructured. It's got a lot of noise in it and all that. And that's where machine learning will extract relevance and make certain inference based on what the machine learning algorithms are seeing. It gives us very powerful task-specific pattern recognition, but requires training and data. Deep learning will bring accuracy and automation to these complex data sets. So I think one of the, we're starting to see this, one of the opportunities out there is just seeing how machine learning kind of gets split into two pieces, learning in the back and then kind of the processing on the front end. And so there's a lot of innovation now that's starting to kind of bring that about. And then, of course, there's acting. So once I sense, infer, the final part at the edge is to act on real-time, act in real time. I already mentioned that, safety and responsiveness requires real-time decisions, that the latency between receiving signals and sending to the cloud for a response is going to be too slow for any even near-time decision. So decisions are going to now have to be made at the cloud, on the edge. And even if it's a wearable device, it may not be connected furthermore, or some remote, a drone or whatever. These devices, as we start to have more autonomy, the importance of processing information at the edge is going to be ever more important. I'm involved with, I'm going to be meeting a portfolio company here called Shield AI right after this. I'm just thinking about this whole autonomy. And they make drones for service members to go into these drones fully autonomously, will go into a building in the battlefield and look for the bad guys in a building and map out a building fully autonomously. So if you think about that, they're really not connected. They'll send back some information to a central pool, but there could be, hundreds of these in a battlefield that will find their way into buildings, and it's got to make all its own decisions, like where walls are and how to go upstairs and fly around a building, and then process that information to send back a limited set of information as opposed to all information, right? Otherwise, it'll be too slow. Furthermore, it's fully autonomous and operating on its own without any operator really moving it in any way, in any way. And so we're going to see a lot of those particular devices starting to get out in the real world. So notwithstanding the edge, all of this information is actually really important. And once it's curated, so let's say I've sense, inferred, acted on the edge. It's still very important. The cloud's relevance becomes important in becoming a training center to learn on the information that's being collected. And what I think happens is you don't need to send back 10 gigabytes per mile from a self-driving car back to the cloud in order to learn learn a more precise, stopping for a stop sign or a red light or whatever. There's curated information that will be sent back to the cloud, billions of devices feeding data back to a central repository, and that's where learning occurs. I also think that the cloud will store important information for future reference. And then once the algorithms sort of learn on this curated information coming from the edge, updates will be pushed back to edge devices to make them better and more aware of the environment. So there's going to be, it's very similar to the world of client-server computing back, many years, 2 decades ago when that was in vogue, where both parts were sort of working together. So here's some predictions. One is that sensor and data explosion will kind of kill the cloud as we know it. Cloud will always be there. Somebody once asked me, in fact, how much processing do I think will be done in the cloud versus done on the edge? And I'll bet you I would venture to say that it's going to be 100 to 1,000 times greater, more processing on the edge than will be done centrally. And just, there'll be sensors everywhere. The existing infrastructure won't be able to handle the data volumes. I don't care if it's 5G, 6G, 10G, 100G. Every time the network has gotten bigger, the data has gotten more bigger. It's always kind of an impedance mismatch between the pipe and the amount of data collected. And we can see this happening right now. Data will be stuck at the edge, and compute will move to the edge to go process that data. We may even return to, I hate to say this, to peer-to-peer computing as edge devices connect, right? Because if I have 2 devices and I want to connect them together, maybe I'm going to see the return of some form of peer-to-peer, whether it's data sharing or compute, that starts to happen at the edge. I think that this is going to fundamentally and dramatically impact networking and security. Because if you think about, you think you have problems now. Wait till 1 billion devices are starting to share information, and we're going to need to solve for the security and networking challenges that come up as a result of some of these new architectures. One of the other things I've been spending a fair bit of time on is to think about if we have machine learning on the, let's say, on the edge, and 1 trillion devices are running various forms of compute, do we need a new programming language to actually support this, right? And I think my sense is that we're going to go to a new kind of a new paradigm in the way we think about programs, that it's going to be data-centric programming as opposed to logically oriented programming. That's what we have today, right? It's if, then, else, and that's kind of been the, the status of writing computer programs since the beginning of computer programs. And I think in the near future, we'll be using data to solve the problems. Neural networks will be built from data, not code. The data will be used to self-reinforce and self-build kind of what's happening on in the next step. And my sense is that this will be a new program. There will be a whole set of new programming languages and new research projects around how we take data and use that to form the basis of next generation applications, right? It's kind of the reverse of what we have today. Today, an application runs and it produces data. And I see in the future, we'll collect data to actually produce applications. And it's sort of an upside down view of the world, but I can see, we're already starting to see some of that happening today, and I think there's tremendous innovation that's going to occur in this particular area. The processing power of the edge will increase as the price decreases. And so, what we're starting to see is that the IoT supply chain is going to commoditize processing and sensors. And it really has started with the mobile phone. Mobile phone has a lot of sensors on it. All of those sensors that are on a mobile phone, that particular supply chain and those technologies can be used in a lot of different permutations and a lot of different applications that will then be used in many of these edge devices. As an example, the first LiDAR system that used to go on top of cars, the self-driving cars to collect map information or those cars to assess their environment around them, first LiDAR was $75,000. Now LiDAR is sub $500, and I'll bet you in the future it goes to $5. So as we start to see these transformations and the amount of sort of the cost of this as driven by the mobile supply chain, we're going to see almost an unlimited ability to take a variety of sensors and put them literally everywhere. This has another, on the power side, it's interesting to note the iPhone 7, which is already, a couple of years old, has 3.3 billion transistors on the iPhone. Probably the 10 has more than that. The original Pentium in 1993 had 3.1 million. So if you look at the scale of kind of and that's in a relatively short time frame. So how many more transistors are we going to pack on a chip that goes into, cameras and sensors to allow us to do some very, very sophisticated things? And so I think that this, whole sensor and being able to run things remotely becomes ever more possible through the use of, through the mobile supply chain acting on these particular devices. I think that, a lot of people, when I've given this presentation, people think, well, what happens to IT? Like, if there's no centralized servers for me to manage or all of that, what happens to IT? I actually think this whole paradigm shift unlocks the power of IT, and the entire world becomes the domain of IT. So there's going to be devices everywhere. I think change is underway, and edge computing will return, just like we've seen from mainframe client server back to cloud and now to edge, disrupting, and I say this once again, disrupting networking, storage, compute, programming, security, and systems management, all to make these particular new architectures work correctly. So I would say get ready for one of the largest transformations in computing. What we saw before is nothing compared to what we are going to see. We got to go manage over 1 trillion devices and figure out how all that's going to work together. And for all of us, I believe that's tremendous opportunity. So here's the final picture. Thank you.